We're going to be using the unit circle to help us find the trig values of the quadrantal angles. The unit circle is a circle whose center is at the origin, and the radius of the circle is 1. So you notice here the center of the circle is at the origin, and it has a radius of 1. So our angle hits the circle at the point xy. Now we know that x represents the horizontal distance and y represents the vertical distance. So we notice that this value from here to here is x, and then we go up y. The unit circle is very helpful because it makes it easy to find the trig values. So as we look at sine, cosine, and tangent, we're going to take a look at these quickly. We have sine of the angle is opposite, which is y, over hypotenuse, which is 1. Well, y over 1 is just y. So sine of A is y. Cosine of A is adjacent, which is x, over hypotenuse, which is 1. Well, x over 1 is just x. And then tangent is opposite over adjacent. This is very helpful to us because we notice that the y value is simply equal to sine of A. And the x value, as we look over here, is equal to the cosine of our angle. So we can make this switch up here with our points. We can say that this point is cosine A, because that's equal to x, sine A, which is equal to y. This is going to help us because we can look at some specific points where the quadrantal angles would cross through the unit circle. The quadrantal angles are angles that lie on axes, so a 0-degree angle, a 90-degree angle, a 180-degree angle, 270-degree angle, and if you go all the way around the 360-degree angle, also you could talk about those in terms of radians, where you would have 0 radians, pi over 2 radians, pi radians, 3 pi over 2, and 2 pi. We're going to label each of these points here because that's going to be helpful to us. So this is a unit circle, so this distance is 1, so this point here is 1, 0, left 1, up and down 0. This point here is 0, 1. As we look here at pi radians, or 180 degrees, we went back 1 and up or down 0. So this is -1, 0. And down here we go left or right 0 and down 1. So this point is 0, -1. So for a 0-degree angle, we want to find sine, cosine, and tangent of 0. A 0-degree angle would come across here, so that would be dealing with this point over here, this 1, 0. So sine of 0, remember, is just the sine of the angle is going to be equal to the y value. So sine of whatever angle we're talking about is going to be equal to the y value. Cosine of the angle we're discussing will be equal to the x value, and tangent of whatever angle we're discussing will be the y value over the x value, and that's how we're going to figure out these quadrantal angles. So sine of 0, we want to look at the y value, which is 0, so sine of 0 is 0. Cosine of 0, we want to look at the x value, so that's 1, so cosine of 0 is 1, and tangent of 0 is y over x, which is 0 over 1, which is 0. Next, we're going to look at sine, cosine, and tangent of 90 degrees. So we're going to be looking at this point right here, which is 0, 1. And we know that sine of the angle we're talking about, which would be a 90-degree angle, sine is equal to the y value, cosine is equal to the x value. So the y value, sine of 90, the y value is 1, so sine of 90 is 1. Cosine of 90 is equal to the x value, which is 0. and tangent of 90 is equal to the y value over the x value, which is 1 over 0. Well, we know we can't divide by 0, so we say that is undefined. So sine, our tangent of 90 is undefined. Next, we will look at sine, cosine, and tangent of 180. So once again, for sine of 180, sine is equal to the y value. Well, the y value here is 0, so sine of 180 is 0. Cosine of the angle, cosine of 180 is equal to x value, which in this case is -1, so cosine of 180 is -1. And tangent of 180 is y, which is 0 over -1. 0 divided by -1 is 0. Coming up to 270 here, find sine, cosine, and tangent of 270. Sine is equal to the y value. Well, the y value of, for a 270-degree angle, which would be here, would be -1. Cosine is equal to the x value. The x value is 0. And tangent of 270 is y over x, which is -1 over 0. We cannot divide it by 0, so that's undefined. Lastly, we are going to look at 360 degrees, which is right here. Well, what do we notice there? 360 degrees is coterminal to 0 degrees. So really, these are just going to be the same as the trig ratios were for 0 degrees. So sine of 360 is going to be 0, cosine is 1, and tangent 0. Now, I used degrees to show this. Also, we could have used radians. So if we were dealing with radians, this would have been 0 radians. For 90, that's pi over 2 radians, so we could have known sine, cosine, and tangent of pi over 2. Over here, that's pi radians. Sine, cosine, and tangent of pi would have been these. This is 3 pi over 2, and 360, that's the same as 2 pi. Once we started filling in these numbers, it was pretty easy because we saw up here, okay, when I want to find sine of the angle, I look at the y value, cosine of the angle, look at the x value, and tangent of the angle, y over x. Just remember that works because it's a unit circle, center at the origin, radius of 1. So you go over x and up y, and then once we then used our definition of sine, cosine, and tangent to come up with these relationships. Sine is opposite over hypotenuse, which ended up being y. Cosine was equal to x. Tangent was equal to y over x. So we used the unit circle to come up with these nice relationships. We actually looked in this direction to help us. Y value is equal to sine of a. The x value was equal to cosine of a, and that helped us find these different things. So that is a key point, using the unit circle to help us find the sine, cosine, and tangent of the quadrantal angles. We then looked at the points we were dealing with, and we knew, okay, for 0 degrees in this case, cosine of a is equal to 1, sine of a is equal to 0. And then tangent of a is y over x. Here, cosine of 90 is 0, sine of 90 is 1, and so on. And that is how we work through finding sine, cosine, and tangent of the quadrantal angles.